Hello geometers, and welcome to the continuing video series on proportionality theorems. We talked about the theorems in the last video. Now we are going to discuss how to apply some of these. So very straightforward problems that are posted here. We just have to find the missing variables. So let's say you have in this situation we want to find x. Well, you can see that the theorem that applies in this case is the last one here, the bisected angle proportionality. Okay. So it says that if you have an angle that's being bisected by a ray, then the two lengths on one side of that ray is proportional to the two lengths on the other side of that ray. So we can apply that to this problem, and we can say that x over 14 is equal to whatever this length right here is over 11. Okay. Now there's lots of ways to name this. We could name this y or z or a, b or c, whatever you want to name it, but I think the simplest way to name it is 20 minus x. Okay? Because the whole entire length is 20, the partial length is x, so the other part of this is 20 minus x. And from here, just some basic algebra, multiply both sides by 11, and then multiply both sides by 14. And just solve that, so we have 11x equals 280 minus 14x. Add 14x to both sides, and we have 15x equals 280. And then do 280 divided by 15. Oh, I realized I made a mistake here. If you add 14x to both sides, you get 25x, not 15. Okay, so 280 divided by 25. When I did that, I got 11.2. So there we have it, solving the first problem here using the bisected angles theorem. So let's look at another example here. This time we have three parallel lines cut by two transversal. So we definitely want to apply this theorem here. And notice here this one says that if you just take the two lengths on one side, AB and BC, then that must be proportional to the two lengths on the other side as well. Okay. So we can apply that to this case and say that 60 over 8x is equal to 3x over 5x. So I'm going to do some reducing here. These x's actually cancel out, so I get 3/5. 60 and 8 are both divisible by 4, so I get 15 over 2x. Then I'm going to multiply both sides by 2x, 6x over 5. Then multiply both sides by 5, and I get 75 over 6 equals 6x. 75 divided by 6 is, of course, 12.5. And so there you have that result. And let's look at the last example here that we're going to do together. The rest of these you're going to work on them on your own, apply your problem-solving skills, and exercise your brain a little bit here. But before we do that, we're going to work on one together. So now we want to think about this problem, what theorem applies. And notice here you have congruent angles. And if you look at this picture here, you basically have a line cut by two transversals. So these are corresponding angles, and that means these two lines have to be parallel. Okay. So again, these two angles are corresponding and congruent, so these two lines must be parallel. So then we can apply this theorem here where you have parallel lines, and that means you have a proportionality. This segment and this segment down here on the left side of the triangle is proportional to the two segments on the other side of it. Except instead of having, you can kind of tilt the picture, right, so that this segment here and this one down here must be proportional to these other two. So this is 21 because the whole thing is 30 and this is 9. Okay? So I'm going to turn this page back around. So I have 21 over 9 is equal to x plus 6 over x. Multiply both sides by x and multiply both sides by 9. And remember to multiply the quantity x plus 6 by 9 and then solve the problem. So 21x equals 9x plus 54. Subtract 9 from both sides and we get 12x is equal to 54. Then divide 54 divided by 12 is, I think it's 4 point something. Let me check. Okay, so this evaluates to x is equal to 4.5. Okay. So there you go. 3 examples to show you how to apply the theorems that we learned. The rest of the packet is your homework. Please work on it and try the best you can with them. I assure you that you have the ability to solve it, and all of the information you need is on this packet. So please work through all of this, and when I see you next, I will help you with some of the problems, whatever issues that you may have. As always, ask for help if you need it. Keep working hard, and have a wonderful day.